Welcome to lesson 8. So in this lesson we're going to talk about language modeling, and we're going to create a language model that's going to test positive or negative movie reviews by telling us which class it belongs to, whether positive or negative. So let's get started with this interesting and exciting lesson. For our lesson 8 we're going to talk about language modeling. So this is going to be an introduction to language modeling. These are the highlights of today's video. This is the objective, and these are the outlines. So first we are going to learn about transfer learning, then language modeling, and after this we are going to create a language model for positive and negative movie reviews. Like we're going to create a language model that's gonna have, like we're gonna input a movie review in it, and it will tell us which class it belongs to, positive or negative. So let's get started with this interesting lesson. So in this lesson we are actually gonna revisit the sentiment analysis, um, or the sentiment analysis task of movie reviews, only using neural networks and transfer learning this time. So it will begin with creating a language model and then using that for classification. So what actually transfer learning for natural language modeling is? So, transfer learning for natural language modeling is a technique where a pre-trained language model is used as a starting point for our specific language tasks, such as text generation or sentiment analysis, allowing it to leverage the general language knowledge it has learned to excel in the specific task with less training data and time. Then language models. So language models, what actually language modeling is? So language modeling is the process of teaching a computer to predict and generate human like text, enabling tasks like auto completion, translation, and chatbot responses. And I also have mentioned some references here to learn and know more about language modeling. You guys can check it out. Using a GPU. So using a GPU, which stands for graphics processing unit, accelerates computing tasks like deep learning or gaming by processing data in parallel, significantly speeding up complex calculations compared to a CPU. So this is particularly beneficial for tasks requiring intensive mathematical operations, making them faster and more efficient. Simple. So then let's go to the code. Okay, so first we are importing the necessary libraries like FastAI, and then setting the batch size for text processing, additionally specifying the GPU. Where is we are specifying? Okay, additionally specifying the GPU 0, and import a function called cosine distance as DST. See, we are importing the cosine distance as dist, sorry. Okay, we'll make it slower. Okay. Then we are for our first exercise preparing the IMDb data. So this code first downloads an IMDb movie review dataset, which we have been using from the very first class. Then attempts to create a language model, here over here, by using a bunch of CSVs, and while handling a potential broken process pool errors by retrying until it succeeds, keeping the track of the numbers of failures and printing them. See the result here first. Okay, see, the failure count is 3, it failed 3 times, and then the wall time is 54.9 seconds. By executing this line, a process was launched that took a bit of time. Let's dig a bit into it. So images could be fed almost directly into a model because they are like just a big array of pixels values that are plots between 0 and 1. A text is composed actually of words, and we can't actually apply mathematical functions to them directly. So we first have to convert them to numbers. This is done into two different steps: tokenization and numericalization. So a text data bunch does all of that things behind the scenes for you. So let's talk about tokenization again. So the initial step in text processing involves breaking sentences in tokens, addressing punctuation, contractions, and potentially cleaning HTML code. So this process actually avoids simple space-based splitting, and instead groups elements like S as a single token. So contractions like let me scroll it down. Contractions like didn't into did and not separately. So the text is also cleaned of HTML symbols and converted to lowercase. So special tokens, often starting with XX as the beginning, are also used for unknown tokens or for distinguishing different text fields within the data. Then, okay, numericalization. So what numericalization is? So numericalization is the process of converting text data into numerical values that machine learning models can easily understand and process. So now, okay, so now first we are using integer to string itos attribute with vocab. Uh, so this is converting the integer values into strings as over tokens. See XX with undefined tokens. You can see all undefined tokens, and one is not the undefined, the last one, the. So then this line of code is actually accessing the text data of the first example in the training dataset of our language model. Then this line extracts for first 10 numerical tokens from the text data of the first example in the language model's training dataset. You can see here extracted ones. See, okay, and then alternative approach with the data block API. So the data block API in NLP provides greater flexibility than default methods, allowing customized data processing like non-random train validation splits. So while using the data block API, you manually can tokenize and numericalize steps, providing flexibility and readability by specifying relevant arguments within each step. So loading and pre-processing our data and forming a data block. So what this code does is these line measures the execution time of the code block below them using this percentage time thing. Then the code attempts to pre-process data from a bunch of CSV files. See, and then for using it for text classification, and it keeps retrying until it succeeds. Let me show you. Yeah, see, it keeps retrying until it succeeds, splitting the data and labeling it with data bunch and all. So it's keep trying until it succeeds while counting and displaying the number of failures due to potential broken process pool errors. Okay, so you can see where does it go? Okay, so you can see the failure count. Okay, you can see the failure count is 0 with wall time of 15.5 excuse me, 15.5 seconds. Then we have transfer learning. So for our transfer learning, what we're gonna do is okay, the first line downloads and extracts the IMDb dataset, storing its path. You can see here, okay. Then the second line lists the contents of the main IMDb dataset directory, this .ls dataset directory, and then okay, then this path /train.ls, what it actually does is it the third line, which is the third line, it actually lists the contents of the train subdirectory within the dataset. So after this, what we have is, okay, so we don't actually the this is the detail thing. I will tell you what it is. So we won't actually train a new model from scratch, but we will use a pre-trained language model originally trained to predict the next word in a sentence, which has valuable language knowledge stored in its hidden state. So to adopt it for sentiment classification, we will fine tune and pre-train the pre-trained dataset pre-trained model on our IMDb dataset, adjusting parameters and accounting for differences in language. Okay. For our another exercise 2A, package the IMDb data into a language model data bunch. So okay, so for this, to fine tune the model, we will create a specialized text data bunch using the data block API, focusing on the unlabeled data, ignoring the labels, shuffling the text during training, and setting targets as the next word in each sentence with an edit try except wrapper to handle a bug in the text API, fast AI text API. Okay. So this code, so what this code does is, so this code measures the execution time. Simple thing we can see here with percentage time. Okay. Then after it attempts to pre-process the data for a language model using the data block API. So what it actually does is, it attempts to label and create a data bunch for our label model, and then the goal is to prepare the data for our training for like to prepare the data for training our language model. Then we are keeping the track of our failures and wall time. You can see failure count is actually 4. Okay, and the wall time is 14 minutes and 18 seconds. So you can see we have keeping the track of that. Okay, I have actually run this code 2 times. So first this and second this. After this, we are checking the length and showing some batches, saving the data bunch for the next time, then loading it again, or saving that save data to actually know that we have saved it, to actually make sure. Okay. So the next exercise, which is transfer learning step. So for this, let me read the exercise. So this is where the magic happens. The AWD slash LSTM object contains the pre-trained weights and the neural net architecture of the Wikitext 103 language model. So what is Wikitext 103 language model? It is actually the language model from Wikipedia. So these will be downloaded for the first time you execute the following line and stored in fast AI slash models or elsewhere if you specify different paths in your config file. Now let's shift to the code. So then we are just testing some we are just getting the dataset. Then we are getting the vocabulary with dot vocab attribute. Then we are converting the string into an integer. See, this string gray is a fish. Simply this is a string. So we are converting the string into into an integer. I have told you, as I have told you, to like for our machine learning model to execute and understand it perfectly. So then we are converting it again to string for just as a purpose of practicing. Then we are converting it into a token. Then we are getting the first one, the first model from AWD. So then we are encoding, you can see within our E and C, we are encoding the thing, model first thing. Then we are getting the size. So difference between IMDb Wikipedia language models. So first we are loading the dataset with pickle library. Then we are getting the first 10 tokens. After then we are checking some length. So this is our first loop. Let me explain what happens here. So this code iterates through the vocabulary of a language model dataset and collects the first 50 words that are not found in another vocabulary called wiki slash int2 string. Okay, and then we are getting we are just appending it. Okay, sure, we are appending it. Okay, sure. Okay. Wiki. Okay, then after it we are converting it to set, both for our both data sets, wiki words and IMDb words. For our tokens, actually we created tokens of our Wikipedia model and our IMDb model. Then we have wiki not IMDb variable. This variable is actually for the difference. Then we are getting some differences between words that are in wiki's model but not in IMDb, and some words that are in IMDb model but not in wiki's model. Then for this loop, so this code repeatedly removes words from a set called uh, wiki not IMDb. Adds them to a list called wiki not IMDb list, appending it by appending it with the append method, and then puts them back into the set, effectively collecting and reusing words from the set 100 times. Okay, then we're getting first 15 first 15 words from our wiki not IMDb list, just to check. Then we again have a loop. So this loop is actually simple, just popping some, like removing something and just appending some words, doing the same as we have done before. And then we are checking some words with some 15 words in IMDb not wiki list. Okay, that are in IMDb but not in wiki's model. Then we are again converting string to integer. We are checking if modernization is in wiki words. It is true. See, true. If we get false, it means that we don't have it in our wiki words. Then we are converting into 30, like converting some string into integer. The same again and again. Okay, so what this code means. Okay, so this all clause means. Okay, so this code checks if the word embeddings for 30 something string and how string. Okay, how string was in here. Okay, for this 30 something string and a link later string. So checks in a neural network model ENC are approximately equal strings using np.all clause. Okay, then we are getting true. So see, we get the result of this. After this, what we are doing is generating some fake movie review list. Movie review list text with the untrained IMDb language model. So this is our untrained IMDb language model. So the first block of code generates two text sequences using a pre-trained language model, which is model. Just 1 minute. Is this what? Okay, so okay. So using the pre-trained language model learn /lm that starts with the phrase the color of the sky is, creating each sequence with 40 words and a temperature of 0.775, you can see, and the temperature of 0.75 to control randomness. You can see it is for randomness. Then see, the color of the sky is used in the Natural Portrait Gallery, London, which was originally the Royal and ahead. Okay, Royal Arcade. Okay, then we are doing again the same thing. So this block of code generates two text sequences starting with I hate this movie, each consisting of 30 words. Then this showcase text generation using the language model, allowing you to see how the model generates coherent and contextually relevant text based on the given prompts. So then okay, so this line again generates and prints two text sequences using a language model learn/lm, starting with the text provided in the text variable. You can see the text variable I hated this movie. Okay, each containing 40 words. A temperature of 0.75 adds randomness to the predictions. Then it displays the documentation for the predict function in the language learner class. Okay, after all, it generates and prints two text generation sequences with a lower temperature of 0.10, resulting in more deterministic and less varied text predictions compared to the first one, the first line. You can see, I hated this movie by John Lennon, and he said he wanted to do it for the American public and all. Okay, so then we are using the doc function, and the things are not repeating, but we are again, okay, I again just run this code. This is not repetition. Okay, then we have our last exercise. The rest of the exercise are like, you have to try it on your own, which are actually based on the mixtures of our 2a, 2b and 2c exercise. So this 2c exercise is about training, fine tuning the IMDb language model, starting with the wiki text 103 pre-trained weights. We will fine tune the model, um, like the model to learn the structure in the language of IMDb reviews. Choose an appropriate learning rate. So choosing an appropriate learning rate. So then this line of code plots the training progress of a language model, excluding the last 15 points. See, the last 15 points are excluded here. Learning rate and the loss. After it, after the first two lines, adjusting the learning rate based on the batch size. So this is adjusting the learning rate based on the batch size, BS, to like to account for different batch sizes, potentially making it smaller or larger. Then we have use the mixed precision type. Then this line actually converts the language model learn underscore lm to a mixed precision training mode FP16, which uses less memory and speeds up over training. Then after this, okay, after this, what this line does is, like, it trains the language model for one cycle with a modified learning rate and momentum values. So here this moms mean momentum values. So okay, see, you can see here valid loss, accuracy, time, train loss and epoch. Then since the relativity is slow to train, we will save our weights. Then we are saving our data and loading it again. Just 1 minute if I just do it like this. Okay, then to complete the fine tuning, we will unfreeze the weights and retrain our data. So we are using learn/lm.unfreeze. This unfreezes the layers of pre-trained language model to allow fine tuning, as I told. Okay, then this line of code learn underscore dot lm fit one cycle 10 lr and momentum size. So this code actually fine tunes, this line actually fine tunes the model for 10 epochs using a specified learning rate lr and momentum values 0.8 and 0.7. After this, we save the fine-tuned data, fine-tuned language model and the encoder. See how we do that? Saving the fine-tuned thing and the encoder. After this, we are loading it to check. Okay. Then this line. Okay. So what this line does is enc equals to learn underscore lm third model at the 0th index dot encoder. So assigns the encoder part to the language model to the variable enc, which can be used for various text processing tasks. Then we have again all clause thing. So all clause function used. So let me explain it again. So this all clause is checking the word embeddings for 30 something and link later in the encoder's weight are nearly identical. So yes, we are again generating the review like text with the fine-tuned IMDb language model. Then we are doing the same thing as we did before, with 30 and 40 variations. See, now let's talk about risks of language model. So what are the risks of using language modeling? So using a language model comes with several risks. I have mentioned here almost 10 risks I have mentioned here as per as my knowledge. So first one is bias and fairness. What is biasness? like creating a bias data. Like if I am conducting a test in our class, and I am giving 10 marks, and I am giving 10 marks to to a student without even checking the test. So this is called biasness. I am biased to her. So creating bias and fairness data from our language models. So language models can inherit biasness present in the training data. So we may have some bias in our biasness in our training data, which can lead to our propagation on stereotypes, discrimination, and offensive content. So you have to be careful with that. Then misinformation and fake news. Language models can unfortunately generate plausible sounding but false information, contributing to the spread of misinformation and fake news. Third is privacy. Generating the text based on our user prompts might inadvertently reveal sensitive information and invade our privacy. So then we have harmful content. Language models can be misused to create harmful or malicious content such as hate speech, harassment, or automated trolling. Then we have over reliance. So relying too heavily on our language models for content generation can reduce critical thinking and creative writing skills. So it can reduce these skills for us. Then we have another risk of security. So language models can be used to craft convincing like phishing emails and other malicious content for our social engineering attacks. Okay, so then we have ethical concerns. We may have some ethical concerns like the use of language models for deep fake generation, impersonation, or manipulation of content ethical concerns. That raises ethical concerns. So environmental impact. So training large language models requires vast computational resources like a GPU, as I told, and has a significant carbon footprint, contributing to our environmental concerns. Okay. Then regulatory and legal issues. The use of language models may raise regulatory or legal questions, particularly when used for generating content that is illegal or violates in intellectual property rights. Okay. Then we have dependency. Over reliance on language models can lead to dependency on technology or content generation, potentially diminishing human creativity and writing skills. To migrate this risk, responsible AI usage, ethical guidelines, and ongoing research into bias mitigation, and content filtering are essential. So to prevent these skills, you have to do this. After this, our third exercise is basically simple. By creating IMDb sentiment classifier, you can actually do this. This code is so simple. See, the way we did before, it's same. Let me show you. Loading and pre-processing our data as we did before. With now with sentiment classification, pre-processing, we already have done this. Then classifying the IMDb reviews for encoder saved data, freezing the data, plotting it, then training and fine-tuning the data, we did before, right? Then okay, unfreezing the data, last 3 layers as it does. So unfreezing all the layers, train for our okay. So saving the IMDb classifier model at the end. Let's look at few examples just to check the IM classifier is working as we think it should. So see, tensor updating. Okay. So the three outputs of the model prediction label POS and negative can tell us POS and or NEG, and the class probability estimates for negative and positive, which measures the model's confidence in its prediction. As we had expected, the model is extremely confident. See, let me show you. See, category positive. I really loved that movie. It was awesome. See, it's the category positive. And then I didn't really love that movie, and I didn't think it was awesome. So see, it has a negative class. See, we succeed in our thing. And then okay. Okay, so now we have built the model. Here is the part where we can get to have some fun. So take the model to for a spin, try out some on your own examples, or search for some new examples. So feel free to explore. Till then, take care and bye bye.